I'm going to go over a couple problems from the Unit 4 Worksheet 6 on graphing rational functions. I'm going to start at number 3. So number 3 it says let h of x equal g of f of x, with g of x equaling 1 over x plus 1 and f of x equaling x minus 3. So part A says to find h of x, and remember this notation means to take f and to plug it into g. So when I do that, I replace the x with x minus 3 and get 1 over x minus 3 plus 1. And there's our equation. Part B asks us to sketch the graph of h of x on the xy plane given. So notice we have an excluded value, x minus 3 cannot equal 0, and so we end up with x cannot equal 3. And excluded values are where you get in your graph, if you graph this, you get a vertical asymptote. So I'm going to put that in here at 3. To get a little more help here with our graph, I'm going to look at part C and part D. So part C asks us to find the y-intercept, and the y-intercept is going to be the value when we plug in 0 for x. And so we get h of 0 is 1 over 0 minus 3 plus 1, which is negative 1/3 plus 1. And I'm going to make that 1 over 1. And I'm going to multiply the 1 over 1 by 3 over 3 to get negative 1/3 plus 3 over 3, which is 2/3. And I'm going to put a little point at 2/3 somewhere about right there. So that's where our graph is going to cross the y-axis. Now for D, we're going to solve for the x intercept. And to find the x intercept, we substitute in 0 for y and solve for x. And so I'm going to subtract 1, and I get negative 1 is equal to 1 over x minus 3. That 1 I'm going to multiply by x minus 3 over x minus 3. And we end up with negative x plus 3 over x minus 3 is equal to 1 over x minus 3. Both have the same denominator, so I set the numerators equal to each other and get negative x plus 3 equals 1, or negative x equals negative 2, so x is equal to 2. And there's going to be our x intercept. Looking at our translation, so h of x, notice that minus 3 translates our parent graph to the right 3, and that plus 1 translates our parent graph up 1. And if we need to know a little bit about our parent graph had a vertical asymptote going right through the y-axis, and or x equals 0, and it also had a horizontal asymptote going through y equals 0 or through the x-axis. And so if you take that and you move it to the right 3, your vertical asymptote appears at 3, which we have. But if you move that up 1, then our horizontal asymptote is going to be at height 1. Oops, I'm putting it at 2, but it should be at height 1. So I'm going to put that in. And the only place it crosses the x-axis, so it goes right in here, and the right side's going to stay up in the top right hand corner. State the domain of H. So the domain of H is from negative infinity up to the break in the graph at 3. Union, start back up at 3, go to positive infinity. And the range, as low as negative infinity up until the break at 1. Union, start back up at 1, go up to infinity. State the equations of any vertical asymptotes of H. So vertical asymptote, we have one at x equals 3. Horizontal asymptote, we have one at y equals 1. State the intervals on which the graph is increasing. Well, if we trace this from left to right, anywhere on that graph, it's decreasing. So it increases nowhere. Where is it? State the intervals on which the graph of H of is less than 0. So it's less than 0 right after it passes its X intercept. So from 2, right after 2, up until 3. Next, let's take a look at number 10. 10, we're given f of x is 3 over x and g of x is 3. And we want to solve the equation f minus g of x equals 0 by graphing f of x and g of x on the xy plane below. So that's part A. Part B, we want to solve it algebraically. And part C, we want to explain the relationship between solving the equation graphically and solving algebraically. I'm going to start with part B first. So f of x minus g of x, so that would be 3 over x, that's your f of x, minus g of x minus 3 equals 0. I'm going to add 3 to both sides and get 3 over x equals 3. And we can make that 3 over 1, and I'm going to multiply that 3 over 1 by x over x. So now we have 3 over x equals 3x over x. Two fractions equal to each other, they both have the same denominator, so we set the numerator equal to each other and say 3 equals 3x. Divide by 3 and you get x is 1. And in our equation we have an excluded value, x can't be 0, and we didn't get that, we got 1. Now graphing, g of x equals 3 is a horizontal line at height 3. So there's g of x. F of x is 3 over x. So this is in the form of the parent graph with a horizontal asymptote along the y-axis. So a vertical asymptote along the y-axis, horizontal asymptote along the x-axis. This is y equals 0. This is x equals 0. And we know that they're going to cross at x equals 1. And we can check that by plugging in a 1 in. If I find out what f of 1 is, I get 3 over 1, which is 3, which gives me a point at 1, 3. And we can see that they're crossing there. We can get some extra points if we want, but what's going to happen here? It's going to look something like this. And this. That's our f of x. And when you're solving this, solving by graphing, you're looking at where the two graphs cross. And so we see that point is happening at the point 1, 3. Part C says explain the relationship between solving an equation graphically and solving algebraically. Both solutions give the same x value.